Hello students, this video is to help with the Unit 5 exam on congruent triangles. I'm going to run through a couple of the possible problems that you'll see, and I'll also give you all the answers to the review sheet. So here goes. This is the first page of the review sheet. You can see, and while I'm going through, if you need to pause the video to take a look at the correct answers, please do so. You can see that we're just trying to name the congruent triangles, and the order is important. For example, this one was OGD. We started from this angle, which had one arc. We went to the right angle, and we went to the two arcs. So OGD. So on this triangle, we had to go from P, which had one arc, to the right angle, to the two arc angle. Order is always important with a congruent statement because the congruent statement's job is to tell you which of the individual vertices are congruent to each of the other individual vertices. So in this example, it says FGH, same idea, FGH. So going in that same order for the other triangle, we had to go FEI. For this last one, a lot of people got this confused in class. The congruency statement here was not pertaining to the picture up here. This is a new congruency statement with no picture attached to it. So what I did was I drew a picture here. And EFI is congruent to HGI, which means that E, which is the first letter, corresponds to H, which is the first letter of the other triangle. Same thing here, FIE, GIH, it's just F to I to E, so the middle to the right all the way back goes to GIH. Alright, the second page coming up here. All of these were just identifying the postulate that makes triangles congruent. This one shows all three sides, so that's side, side, side. Same thing, all three sides, side, side, side. Hypleg was one of the ones that students got confused about in class. Hypleg requires a right triangle, and if you can identify the hypotenuse and at least one leg, that means you can use Hypleg postulate for it. Here are the other answers for some of the other questions down here. And then for question 17, it was given that BD bisects ABC. You needed that because, unlike some of the other problems, you didn't know that these two angles were congruent unless it was told to you. And that's the statement that we wrote here. Alright, next page, moving through a little quickly. These mini proofs were interesting because you didn't need to write down any of the givens. Like, they gave you this right angle, they gave you this congruent side to this, they gave you that CE is congruent to EA using markings. You didn't have to write that down, but you did have to write down that CED is congruent to AEB because vertical angles are congruent. So again, with all these other ones, we didn't write down any of the givens. We just wrote down the postulates that we needed. Incidentally, this one, question number 3, gave students a hard time. You actually were not able to prove that these triangles were congruent because angle side side is not a very appropriate way of proving triangles congruent at all. In fact, it's not one of our postulates. So you saw these ones already. And then here's 7, 8, and 9, angle side angle, Hypleg, and ASA. Alright, moving on. Oh, one quick thing about this. We know that BR plus RT is congruent to TP, plus RT. That's the addition property, or addition, that's the addition property of equality. And then BT is congruent to RP, that's addition postulate. These two properties and postulates will be coming up later in some of the proofs. Alright, oh, this is sideways. Hold on, let me try to turn this around. Alright, I had to do a little minor surgery to my computer, but it looks like now it is showing the right way, so you don't have to turn your monitor or your phone sideways to view this. Anyway, we tried to use colors here to identify some of the individual parts that needed to be shown congruent. This question was a little strange because it gave us a postulate. It sort of gave us the correct answer, and then it asked, well, what other information do I need in order to prove the triangle is congruent? So we said SAS, but it only gave us this green, FE is congruent to DC, and it also gave us this orange, which is FEA is congruent to CDB, respectively. So in order to prove triangles congruent using SAS, we already had a side and an angle, we just need a congruent side. So AE is congruent to DB, it's highlighted here in purple. We did the same thing for most of the other examples here. AC is congruent to AC is reflexive. It did not need to be given to us, but it also doesn't need to be shown because you can figure it out. It could be concluded visually. In other words, it's obvious. However, if I wanted to prove side, 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 I would have to take the given information here, the green, combine it with this reflexive property. They needed to tell us that BA is congruent to AD. All right. And that is the end of that page, so we're moving right along to the next page here, which is the practice proofs. I'm going to let you take a look at this practice proof for a moment, so go ahead and pause the video if you need. One important strategy that you should be able to see in this proof is taking a overlapping set of triangles, or triangles that are at least meeting at this one intersecting line, and trying to separate them into their own triangles. If you separate them out, you can see them pretty clearly. You can see that this is the reflexive side, that's NK, which is the same in both triangles. You were given the information about this angle N and this angle N, and you were able to take this 2 plus this 1 and turn it into this 3 hash line. Same thing over here. That's what I was talking about before with the segment addition postulate. It just says that if you add two things together that are equal with two other things that are equal, the sums must be equal. So in other words, if I did, 2 plus 1 equals 2 plus 1, that of course must be equal. That must be 3 equals 3, and that's this part down here. I didn't know these measurements with numbers, but I knew that this was equal to this, and this was equal to this. So that means that ln has to be congruent to nj. All right, here's the second proof. Again, pause the video if you need, take a look at it. Again, you can see the redrawing of the two triangles. It makes it a little bit easier to see. And these were pretty quick proofs, very straightforward. For letter B, describing a rigid motion or sequence of rigid motions, this is not something that you should have forgotten since Unit 4. It's still something that you need to be able to do. Here's our third proof. Notice that I grouped all my givens together. That's all the givens that were here. And this was very straightforward as well because we were able to just use reflexive property to pretty much solve it right away. All right, moving on to the next page. Why is this blank? Stand by. More computer surgery. All right, after many attempts of trying to make it work with that one program, I'm using a different program now. How exciting. Anyway, here's the proof that I was talking about. This was a little bit longer than the previous ones because we had to prove that M is the midpoint of JK. We needed to first prove that these two sides were congruent. JM is congruent to MK. And then we were able to use the fact that if a point cuts a segment into two congruent parts, then the point is a midpoint. This could all be replaced with two simple words: midpoint definition. You guessed it. Well, hopefully you guessed it anyway. Here's proof number 5. Proof number 5 was another fairly straightforward proof. All it needed you to do was prove that the two triangles were congruent, and we used angle side angle. One thing that I must stress to you is that once you're given this information, you should label the diagram. This was pre-labeled, but you need to be able to label it yourself and come up with a strategy. So you should have been able to figure out angle side angle just by looking at the diagram, and writing the proof should be more of a formality or more of just an organizational thing. Here's proof number 6. Segment addition postulate again. Remember what we were doing is taking two like quantities and adding them together. So this green plus this blue is equal to or congruent to this green plus this blue because we were given that they were congruent to each other before. So left plus left should be equal to right plus right. Please remember the segment addition postulate as it will be important. Anyway, take a look at this next proof here. This is proof number 7. You'll notice that this step, which is step number 4, this step is actually a little superfluous for this particular proof. The proof is a hype-like postulate, which means we need to prove that it's a right triangle. So that's statement number 5. Statement number 4, you did not necessarily need to add in because we didn't need to know that these two angles were congruent. Because once we know that it's a right triangle, once we know statement 5, all we needed to do was prove one hypotenuse and one leg, and that's what we did down here. Again, statement number 4 can be deleted for this proof, but it is necessary for other proofs. Like, for example, if we were trying to do side angle side, we might take this side and this angle and this side and say that they're congruent, for example. But not necessary for this proof. Here's proof number 8. In proof number 8, it was another proof two triangles congruent proof, and of course, you do need to identify the two triangles by drawing them separately. Angle side is what we ended up here, and notice that for number 2, you can say, instead of in a triangle sides opposite congruent angles are congruent, you could say isosceles triangle definition or definition of isosceles triangle. Vertical angles, something that you should know since you were like 1 year old, and then angle side. Question number 9 was another example in which I could have drawn these separately. I just decided not to because they were very straightforward. They were very easy to see. Alternate interior angles is all you had to write here. You didn't have to write alternate interior angles if parallel lines are congruent. And then for question number 10, here's another example in which we took a look at the two triangles that were in a larger image. And this one, it was a little strange because we proved two triangles congruent right in the middle here. But we needed those two triangles to be congruent so that we could show that two sides were congruent. So we used CP/CTC right in the middle here. So this is kind of like we used information that we had in order to come up with the information that we needed. So that's the end of the review sheet. That's all the information that was given out in class. However, there are a couple more things that you should look over and review in order to prepare for this Unit 5 exam. Here's one example of some information that you're going to need for this Unit 5 exam. In this check for understanding from lesson 10, it asked us to prove that triangle JEN is an isosceles right triangle. There are two pieces of information that we need here. We need to identify whether it's isosceles, and that we did here using the distance formula. Isosceles just means that two of the sides are congruent, and we found that JE and EN both have radical 20 as their distance. So you do need to be able to use the distance formula to find sides of a triangle. We also need to prove that JEN is a right triangle, and we do that by proving that the two sides that meet each other at a right angle have negative reciprocal slopes. Here's -2/1, here's +1/2, so that means they're negative reciprocal slopes. You finish up this proof by writing out a couple of different sentences, and I'll show them now. And here you can see the writing piece that's necessary. JE is congruent to EN due to the distance formula, and then we can prove that JEN is an isosceles triangle, saying that two sides are congruent. Further, we can say that JE is perpendicular to EN, which means I have to write in this symbol for perpendicular. No, computer drawing programs aren't all that they were meant to be. Perpendicular to EN because of negative reciprocal slopes, and angle JEN is a right angle because of the fact that they're perpendicular. Since they're perpendicular, that means that JEN is a right angle, and since there's a right angle there, that means that JEN is a right triangle. So you should be able to write all of this down with some degree of fluency. So if you're not really sure what happened here, you should take a look at that lesson. That was lesson 10. We're moving on to the problem set. I'm going to give you a couple of the selected answers from this problem set so you're better prepared for this exam that is coming up. Take a look at these and I will give you the correct answers in a moment. Alright, for each one of these problems you can see that when we found all the distances, I didn't show you all the distance formulas here, but when you found the distances, these two distances were the same. 4 and 4 were also the same, and 10 and 10 were also the same. So using the distance formula, you would be able to classify these triangles as isosceles. Keep in mind, if it was scalene, then all of these three numbers would be different. And if it were equilateral, then all three numbers would have to be the same. We would be able to prove that it is a right triangle or not by basing that on their slopes, but none of these triangles happen to be right triangles. Alright, that is, as I said before, that is the video on reviewing for Unit 5 test. Good luck studying.